Hi everybody, thank you very much for coming along. I appreciate it's the last day, it's after lunch. Bravo, well done to you. So hopefully I can entertain you for 30, 45 minutes. My name is Mark Hannell. I'm the VP of Open Research at Digital Science, founder of Figshare. And my co-author is Bella, who's at the front here. And she is from Singapore Management University. And we're going to be talking about largely around a survey that we do every year to understand researcher attitudes towards open data and where do we think it's going. I think it's really going to be a what's happened, where are we now, and can we predict the future? And I know that we can't predict the future, but I'll have a go. And you can ask questions and call me out on it. So if we start with where we are with data right now. It might seem like a new area for a lot of people who work in libraries, who work in publishers, that the idea that data is kind of a problem we'll have to deal with at some point, but I already have enough problems dealing with getting every researcher an ORCID or encouraging them to follow the open access policies and things like this. And so this graph is just showing the cumulative number of publications, data sets, and preprints since the turn of the millennium. And if you look at the data from Dimensions, you can see that Dimensions knows about 66 million data sets. So it might seem like a new area, but 66 million data sets, academic data sets, is a lot. We know about 160 million academic publications. And if you catch me afterwards, I can tell you that I feel this is too many publications. We don't need that many publications. The tension here, which will be a tension throughout the talk, is that AI researchers will tell you we don't have enough publications. We don't have enough data. And so whereas the current publishing system is starting to creak a little bit, if you look at the year 2000, we got 2 million academic papers a year. By 2020, we were getting 8 million academic papers a year. So that's 4 times as many peer reviewers, but we didn't have 4 times as many researchers. So you can see why the tension there is that we're starting to, the publishing system, as some of you may know, is starting to creak a little bit of how do you sustain this. And the AI world we live in now is saying, I need more data, there's not enough data, there's not enough papers. Preprints is also an interesting one. We're seeing a lot of preprint platforms saying that they're being inundated with AI publications. So again, more content, but is it really novel content? Is it really new content? And so if we say, why are researchers publishing data? You may think it's still early, but if you look at the 65 million data sets already being published, then there's a big volume. So what's encouraging those researchers to do that? In February 2022, the NIH said, if we fund you, biggest funder of biomedical research in the world, said, if we fund you, when you publish your paper, you have to make your data available. So that'll incentivize a few people. And China has the new 2025 action plan to build a digital China. It talks a lot about AI readiness, AI plus, and data set availability. So again, globally, East and West, we're seeing researchers being told you should be publishing your data. So we know researchers are publishing their data. We know they're being told to by the people who pay them to publish their data. So why is it still seen as a new thing? Why are researchers not necessarily happy about it? Well, we think that it's a carrots and sticks world. So the sticks are the researchers being told, you need to make your data available. The carrot is, if you make your data available, you can have more impact. You can get more citations. You can advance your career. And we have the data to back that up. We've had the data to back that up for 6 years. If you make your data available and link it from your paper, citations to that paper, on average, go up 25%. This is on 500,000 papers. So we can say confidently that if you make your data available, it's good for your impact. Researchers don't believe you. So this is from this year's State of Open Data. It's the 10th anniversary where we've surveyed researchers around the world in partnership with Springer Nature. What are your attitudes towards research data? And every year they say the same thing. I don't get enough credit for it. I don't get enough credit for making my data openly available. Interestingly, the new data that came out on Monday, we've just released this, you can go to stateofopendata.com to play with it. It does look like there's a little trend here that researchers are starting to think that maybe I get some credit for sharing my research data, but still 70% of researchers don't think they get enough credit for sharing their research data. If you ask them about their opinions about open stuff, I could survey everyone in this room and say, who here thinks that open access is a good thing? Put your hand up if you don't think open access is a good thing. I don't want to put you on the spot, but nobody's very, yeah. So it's very easy to have an opinion like that, right? So this is saying, do you think that research articles should be made openly available? Do you think that research data should be made openly available? Do you think that peer review should be made openly available? And do you think that preprints should be a thing? So these are all attitudes toward open research. And over the last 5 years this is looking at, you can see that the green is strongly agree. So people agree that you should make papers available, data available, but it's not going down. They still think you should be making all of these things open. If anything, it's nudging up, right? So researchers don't think they get enough credit for making their data openly available, but they genuinely think, yeah, we should do it. It's good for humanity. It's good for the world. It's easy to say. So when you ask them, how would you feel about your national funder mandating that you make your data openly available? If you look at the 10 years of us doing this survey, in 2016, everybody was up kind of 50% and above with people saying, yeah, I support that. Because just like I believe in open research principles, I also think that we should, if the funder mandated making our data openly available, that's a good thing. And it's come down in every country over the last 10 years. And that is because, in my opinion, that is because researchers are being told, you need to make your data openly available. You think it's a good thing. The NIH says at the point you publish your paper, you should publish the data. And the researchers have suddenly realized, well, this is more work. I've already got enough things on my plate. I've already got to publish my papers. I've got to write my grants. And now you're telling me I need to prepare all of my data and make it openly available. And so people do it as a box-ticking exercise. I have to do it. I'm not going to describe it well. I'm not going to make it findable, accessible, interoperable, and reusable. This concept of fair data, which is very important. And so why are the funders telling you to do this? If you go back to 2011, when I started Figshare, there was this book out by a guy called Jim Gray who said, it was the fourth paradigm of research. He said, in our lifetimes, if everybody makes all of the research openly available, the computers will come in and find new knowledge. And that seemed like a great thing to aim for. And I was like, maybe in my lifetime that will happen. And then fast forward a decade, the Protein Data Bank had 200,000 structures of protein folding 3D structures. So we know what the chemical sequence of the protein is, but we don't know how that protein folds. So over the course of 30 years, Protein Data Bank had one experiment done by different research labs, on and on and on. It was people's whole PhD project to do this crystallography image of a protein folding. And so they ended up with about 200,000 of these structures. Each structure cost $100,000 to do the experiment. So you're looking at, that's $20 billion of research has been done to get this data. And then Google DeepMind came along, and overnight they said, we've gone from 200,000 structures to 1 million structures. And then a year later they said, we've actually got 200 million structures now. we know how every protein in humans folds. And that's not only a shift in the research, it's also a financial return on investment for the funders, where getting up to 200 million protein structures the old way would have cost, I had to Google that number, $20 trillion. So it's a $20 trillion saving. That's good for the funder, right? But it also, if you just want to take a step back with me and think about AI, it's all we hear. We've heard it in every session. It is fundamentally changing things. But it's really fundamentally changing things in two ways. One is it's making us faster at doing things, and there's compounding speed increases, which will help research move further faster. But the other thing, which I think of as the holy grail here, is it's creating new knowledge. So this has created new knowledge. And this is why they won the Nobel Prize for Chemistry in 2024. Because they fundamentally changed an area, they created new knowledge. So you can see why it's useful for the changing of how we progress science if we can make our data openly available, if it can be reused, and if we can create new knowledge. So how do we encourage researchers that they need to make their data available so they can create new knowledge? We want to make them aware of this concept of fair. And this is how fast things change. So for the last 10 years, if you saw me do a talk, I'd probably have that picture in. Findable, accessible, interoperable, and reusable for humans and for machines. And then the machines started taking priority. And now I don't think, machines have a different kind of intelligence. Now I don't think we need to make it fair for humans. Humans can work it out. If you've got a not well-described data set that links to a paper, the human knows to go to the paper, look for the method, see what's going on. But machines are operating at a much bigger level. And so we should realign academic data for AI. The best way for humankind to benefit from research is to prioritize machines over people. And that as a message, I think, is an important one. But again, if researchers don't want to do this, it's also not very motivating to say, well, we want to make you the input for these machines. Because if you think about who is in this tension of there's too much information, there's not enough information, the publishing system says there's too many publications, we're struggling to deal with it. The AI system is saying, well, we've eaten all the data on the internet. I need new knowledge. So the two ways to get new knowledge is for AI systems to create new knowledge, or you go to the people whose job it is to create new knowledge. And that's what research is. And that's what librarians are. They're the gatekeepers of this new knowledge. So it puts everybody in this conference at the center point of a critical thing moving forward. And that's important. So good news when it comes to our survey again, and we look at 10 years of data around, have you heard of FAIR? Never heard of FAIR, going down. Familiar with FAIR, and heard of it, but not familiar, going up. So generally, globally, we're seeing that people are more familiar with FAIR. They know that there's this concept. If we look at different subjects, it's across all subjects. So you have the dark green here is I've never heard of this in 2016. And the light blue here is I have heard of it. So in 2025. So every subject has seen a change. Every subject people know about. In the State of Open Data report for this year, we've made the data all available. You can go and slice and dice the data. And you see country differences as well as subject differences. And I was chatting to Nobuko before about this, that for some reason Japan doesn't seem very familiar with FAIR. They have a national mandate. I don't know if it's a language thing, but when we look at China, the Chinese Academy of Sciences has done their own report on top of our survey data for the last 3 years. And you can see just in the way they write their report, it's the same data, it's just filtered for China. But they care about different things. So we have a lot of talking heads, experts in the field, looking back over 10 years in this year's report. And they very rarely mention scooping IP protection, but this is something that Chinese researchers care about and say their biggest concern about making their data available is being scooped or people misusing the data. So there are cultural differences that we need to be aware about, and obviously at the macro global economic level, there are differences as well, right? Especially now, there is the AI gold rush, there is AI models being developed in the East, there's AI models being developed in the West. There's this conversation about whether we'll see a tension here of people restricting data being made openly available for everyone, or just made available to people in their country, for example. Good news from the report in China as well. 87% of respondents report their data sharing practices fully or partially comply with FAIR principles. So FAIR is a global movement. Everybody knows that they should be doing this, except in Japan. But when we talk about like where the gaps are and how we can speed this up and how we can help, I should also say, by the way, Japan has a national mandate. Japan has a lot of infrastructure, so there's just subtle differences. I'm not riling on Japan here, but there's a lot of countries where they think again. Not only do the researchers say we haven't got time for this. Do we have any librarians in the room? Hands up if you're a librarian. Couple, yeah. I'm guessing you don't feel like you have a lot of time on your hands to do new things. So when I say, you've got to encourage researchers and train them about fair data, that's just another thing that you've got to hammer them over the head with. And it's hard because people are aware of this, but they see it as more work for them, so you've got to try and encourage them. And it's hard to get that support. It's hard to see the benefits of supporting researchers if they don't want to do something. And you see regional divergence and discipline disparities. But what Suni says is very important in terms of we'll continue to do these things. We'll continue to try and incentivize researchers and just keep trying to slowly and steadily educate the researchers. And we can incentivize them with prizes, like the Singapore Open Research Conference. But also, the point she makes about it's not just about fair, it's about the university is looking how to make it fairer, where E stands for ethical and R stands for responsible. And this is the biggest kind of what the last 10 years look like, what the next 10 years look like. The last 10 years was encouraging people to put files on the internet. The next 10 years is how do we make that data useful and fairer. And Melissa Handel has a quote in the report where she says, the next 10 years are all about value, not volume. Just having the most number of data sets means nothing. It's useful that it's out there, but what are the valuable data sets? That's the ones that will really get your university more credit. So the last couple of years, this survey has looked at use of AI tools. And what's interesting here is, Darway mentions, in the future, there could be tools or models that automatically identify data discrepancies, correct them, and improve them with minimal human intervention, which is scary for a few people. But I'd argue that if you're a researcher who made your data available 5 years ago, and you didn't describe it well because it was a box-ticking exercise, then someone's going to describe it well for you, and you've lost your chance to do that. The AI graphs, again, we've done this survey for 10 years, and in 10 years, it's very hard to make it interesting that, the people who are aware of FAIR has gone from 38% to 39% to 41%, right? It's just steady progress. But as with everything AI, in a year, we've gone up by 10% in terms of researchers who are making use of AI for data collection, data processing, and metadata creation, like Darway suggests is going to be a thing of the future in making data more valuable. These graphs are the other way around, but if you look at the green numbers, on the left-hand side you have Japan, on the right-hand side you have China, so you can slice and dice this in different ways. Again, data processing, starting using or using regularly is green, and you see that in 2025, for metadata creation, for data collection and data processing, these numbers are going up at huge rates in China. So researchers there are obviously being educated better, more about how to make use of AI in order to make your data more valuable. So we can learn things from different countries, we can see who's doing it well, and try and understand what they're doing to copy them. And this is all a bit end of the world. This is all happening without us. You know, the data is important. New models are coming around where they say, you know, Google DeepMind has started a research lab just to do basic research, right? Because they're saying, we can't rely on academics to make their data available. We're just going to start our own research labs. But they probably won't make it openly available for everybody. So it's a confusing time. But why would you at your university try and push this forward? What's your incentive to try and do this? Or if you're a publisher or anything like that? Well, in our last year report, we looked at for 10 years, we've done the state of open data and surveyed what people say they're going to do or what their opinion is. But it's not really, how do we know what they say they're doing is actually true? And the data citation corpus was the first way to do this. It glimpses at, it's not a perfect methodology, but it shows you what's coming. And so they said, for every academic paper, how many links to data sets are there? And this is interesting for a few reasons, because you can start ranking people. This is the ugliest graph I'll ever show, but it's got lots of data in here. And what I love about this section of talks is as soon as you put in country ranking or university ranking, people lean in. People are like, where are we on this list? How am I doing here? And so this is saying, what percentage of papers from this country have a link to a data set? So, you know, in the year 2000, it's basically 0. Sweden is winning of the big countries, but you can see a range. Most people are going up and to the right, so you can see a lot of grouping together between UK, Italy, China, South Korea. There's, you know, it's not, there are regional differences, which I'll show you in a minute, but it's not east versus west or north versus south. It's happening everywhere. So this is, you can play with this at bit.ly DCC Open Data, and you can see in more detail. I just thought I'd put bit of Asian competition in for Charleston, Asia. Get you all excited for next year when you can see how you're doing and if you're winning the battle. So Thailand is doing very well when I compared these countries. China is doing well. South Korea is doing well. You know, there's competition here. There's ways in which you can talk to researchers in other countries and understand what's going on. I even went down to the university level, and I'm not going to read out the names because you can fight amongst yourselves. But what's really, really interesting here is if we think about these tensions, and if you think about where we're coming from and where we're trying to get to, the researchers don't want to make their data openly available, and one of the reasons they give is we're not incentivized. The National Institute of Health has already started saying, we came out with a policy, then we made it a mandate. You could check on compliance, and then measurement. This is how societal change in academia happens. You've got to go through that pathway. And the NIH seems to be speedrunning it, because they said, well, we've got a mandate, started January 2023. They're already able now, with these new metrics, to measure how many of their papers link to a data set. And you can see it's going up and up and up. And now, through the National Cancer Institute, they have this S-Index prize, which is coming out and saying, we want to come up with a new metric to reward exemplary data sharers. So that whole idea of, I'm not going to get enough credit for my work, if you are making your data available, there is going to be an S-index. If this funder's doing it, then maybe every funder will start doing it. And if you focus at the top level of, well, different countries have different political agendas, different countries have different cultures and things like this. So maybe we'll get to a point where researchers in different countries are changing the way they act or changing their policies. But the thing that motivates me here in the incentive structure is if you're in China, I just said this speller, if you're in China, you still want to publish in Nature. You may not agree with the idea that it's not one of your country's journals or what have you, but we have a reward system in academia that people care a great deal about. Universities, funders, countries. That's not going away. So if one funder starts recognizing data sharing, other funders are going to start recognizing data sharing, other funders are going to start caring about these metrics of we're the best at this, we're having the most impact with this. And so we go to a world where 10 years ago, we said, you really should be doing this, but we can't give you any reason to do it other than the good of humanity. Then the funders said, we're going to make you do this. Then AI came along and said, this is going to fundamentally change the world. We're going to have new models for making data openly available. We're going to have new incentives. People are already winning the Nobel Prize for reusing open data. And I just wanted to highlight this to finish off, that yes, the boring part about it is that researchers will need to continually be told what to do, continually need to be educated. There's no silver bullet here. There's no magic fix. You have to just keep educating them. And for those parts of the world that said, well, we're under-resourced when it comes to this compared to, Western Europe or North America or China, if you look at those metrics again of a proxy for which countries are doing the best when it comes to data sharing, what percentage of your papers have links to data sets, then gold is good. So we heard about Sweden doing well and Northern Europe is doing well, but also Central and Eastern Africa are doing really well as well. The purple parts have more to do, but can catch up. And those countries are not rich countries with massive infrastructure. They're just doing better at the education of their researchers. The infrastructure is there. There's free tools available for them to do it. It's just a question of, can you do the boring stuff and just repeatedly tell your researchers to do this? We'll keep working on trying to encourage them and understand why they're doing it. But I think when it comes back to what does the future hold and what does the next 10 years look like, I think research data, my predictions are research data is going to be more important than the papers. I think we're going to see more private research creating data sets that the public doesn't get to see. And I think the libraries, the publishers, and the researchers themselves are going to become more important as knowledge creators and knowledge custodians, as they always have been. But in a way that is financially supported outside of the traditional academic system, as the AI wants access to all of this data. So that's my 10 years looking back, 10 years looking forward. If you want to hear Bella's thoughts, she's happy to answer any questions from the academic point of view, from the institutional point of view. But otherwise, thank you very much, and I'm happy to answer questions. For those interested in the papers, the Chinese State of Open Data from the Chinese Academy of Sciences, that report came out yesterday. It's on Figshare. And if you go to stateofopendata.com, you can find access to all of the data, all of the sources. You can dig around and see your own institution, your own country. Questions? Yes. Yeah.
I guess what I'm more interested in is that if you're looking at that DeepMind piece that you put up there, is what actually publishing your data does for the efficiency of research. And I just wonder if we're close to getting a stat about that. And the DeepMind stuff was really fascinating because you can immediately see how it can contribute. But can we replace that citation stat almost with this is making research more efficient, do you think?
Yeah, that's a great idea. I think there's a conversation about how can you say it's specifically this that's driving more efficiencies, because I think we're also going to see more the speed of research improving just because people have AI tools to speed things up for them. I think the idea that you can get 25% more citations and things like that, it's still, the tension point here is even when the NIH stuff comes out and they start ranking you, that's the first step in the motivation. But we still have problems with credit in the new system. The same way that if you're a publisher, you're probably wondering, how do I get my papers to be the top search result when people ask a question in ChatGPT, right? It's a whole new field for you. Then you also have the problem with DeepMind that, 170,000 data sets on Protein Data Bank. Nobody from Protein Data Bank got the Nobel Prize. None of the 170,000 researchers who'd made that data available got any credit for it, other than knowing that... Or money. Yeah. Demis Hassabis of DeepMind got knighted and won the Nobel Prize, and he's already a billionaire. So, it's like, there are problems that we're going to have to work through, and there are issues with the new system, and that's what I'm most concerned about is, like DeepMind doing its own research.
Yeah.
What happens to, if knowledge becomes, new data, new knowledge becomes the most important thing, then it becomes an asset. And so, a university is going to start scooping up their data and saying, we'll sell it to DeepMind. But, I don't want to put ideas in anybody's heads. I think the idea of a metric for the efficiency of research is a great idea, and I'd love somebody to do it, to thought about it a bit more. Any other questions? Yeah, go. Say thank you.
Hi, Mark. So, you've got a 10-year longitudinal view of this now, which is very cool. And it started when FAIR started. You're looking at FAIR principles, and that's about getting data AI ready. And then a decade in, and you've started tracking stuff on relating to AI now, but just like the last year or two. And, fairness was getting it ready, but then actually use it. What are your thoughts for the next decade on AI standards, like model cards, data cards, people who are working in the AI standard space? Is this post-FAIR, or what do you think the next decade will hold?
Yeah, I think there's a lot of new tools where with the free Figshare, because it's not curated, it's slightly curated. We have a lot of people we have a new problem of a lot of people writing papers where they've got this new co-author who tells them, what a great idea. You're absolutely right. Let me apply the fundamental laws of physics to your random concept about space travel. So we have this credibility issue of content coming through. But we always used to say that tools like Figshare can make data fair if the human describes it well. So the boring stuff on the side of things like that, I think that there's a lot of standards that you can do now with things like Quasson ML.
I was thinking Quasson.
Yeah, so you've got ways in which you can mark up the data, and this is the responsibility of the technology platforms to do that, because the researcher doesn't need to know about that. There's an initiative that's come out of Frontiers called FAIR Squared, and what's really nice about it is it does create very fair for machine data already. It's done it with a paper wrapper, but that's a really cool advancement in the space, and I like the fact that people are innovating in this space now, and it's playing well in that it gives you a certificate. You have made your data fair. So I think meeting researchers where they are and encouraging them to do things like that is the way forward. I think we'll see new standards evolve for AI interoperability. I think we'll see people marking up a lot of open content with, semantic web knowledge. I think there's going to be tons of innovation there. I think there's going to be this weird kind of what do we prioritize first as the tech platforms.
Yeah, I was one of the authors on the original FAIR paper back in the day, but seeing it's gone up to 40% of people actually know it, I didn't think back then, it would, it's still 60% to go or whatever, but it's done really well. And these new standards we'll see in a decade where they end up as well. But.
Yeah, somebody sent me something called, I heard it in a talk earlier, how do you describe when you've used AI in your systems? And somebody had come up with something called AIR, which is AI reuse or something. And so for every point at which you do your research, have you mentioned how you've used AI? And are we just compounding information, or are we creating new knowledge? It's cool stuff as well. No, good.
Thank you. Hi, Mark. We've talked about this, you and me, but I thought it might be worthwhile bringing this up publicly. For Japan, there is Japan Link Center, minting DOIs both for publications and datasets, and those metadata attached to these DOIs don't circulate too widely. Yeah, so some of your graphs, especially the agri ones, I think that's actually missing because you are only counting the data site DOIs. Yeah, versus there are more data sets coming out from Japan that are minting JAWG DOIs. Yeah. And this is not quite international problem. This is more like our country's problem. We're going to have to do something about it. But I was wondering if there is any thoughts about it, because not only Figshare did digital science, but also you were also wear the make metadata count hat as well, right? Yeah. So what's your take on this? And is there any other similar phenomenon happening other than Japan?
Yeah, it's a balance, right? Because there's all these tensions and there's all these motivations to act in a certain way. And so you're very right. The sweeping statements I made in showing you graphs with hundreds of lines on, if you double click into that, that there's differences and there's reasons for this. And, Indonesia doesn't look great on that, but it has its own, e-prints publication system that may not be getting picked up in the same way. And so I think on the one hand, it's great that you can encourage people to be interoperable on a global scale instead of creating your own things. But I know that takes work and it's political. The counter to that as well, though, is you see in Africa, they're starting the Africa PID Alliance. Joyo Wango. So you're like, that's good because they want to develop skill sets and they want to develop Africa-based tooling. But they might not show up in my graph where I take the path of least resistance and just get as much data as I can at once. And so they'll do poorly. So it's a tension. I think we'll see more disparity, but it also encourages me that going back to the global prestige in academia, any of the countries that say we're going to cut off will also cut themselves off from prestige, which they seem to care about. I don't know why.
Right. Okay. Thank you. So I just wanted to make sure that, in that picture, Japan is stopping at far.
Yeah. And you're
we
doing
need to make it I and R more.
And you're doing a survey to find out more about the Japanese researchers themselves.
Yeah.
So watch out for that paper.
Thanks.
Okay. Thank you very much for your post-lunch time. Enjoy the rest of the conference. Thank you.